Okay, in this lecture we're going to talk about some very simple models. These are what we call linear models, and they come in the form of linear equations. Now remember that mathematics is about modeling the real life, and one of the simplest models is a linear equation. And we're going to talk about some of the skills needed to solve linear equations. And it's really built upon one particular property, and that's called the property of equality. Now, the property of equality says this, okay? If I have any real numbers, and let's call A, B, and C are real numbers, okay, then if I have that A is equal to B, then I have that A plus C equals B plus C. So this is one of the golden rules of algebra, that is that if I have an equality I can add the same to both sides and it remains the same. I just can't add it to one side because it becomes unbalanced. We also have the case that if I have C is not equal to zero, not equal to zero, then I also, if A is equal to B, then AC equals to BC. Now, when it comes to a linear model, which we are going to call a linear equation, the standard type of form for a linear equation in one variable, in other words, we've got one unknown quantity, okay, is the form AX plus B equals 0. This is what we call standard form, okay, and of course A is not equal to 0 here, otherwise I'd just have a number equal to 0. B would be 0 as well. Alright, now our objective here is to actually solve some linear equations using the equality rule. So let's suppose I want to solve negative 4 by 3x take 4 equals 3 subtract 5x plus 3. Right, now here's our equal sign right here. Now the first thing we must do is apply the distributive property, so that obviously our objective in solving this is to find out what x is, so we need to isolate x. So let's first of all distribute. So negative 4 distributed here would give me negative 12x. Negative 4 distributed here, negative 4 by negative 4 would be positive 16. And be careful here, this is not 3 times negative, this is 3 minus this, so I need to apply the negative to the inside here, which means I need to take away or change the sign of each one. So I end up with this. Right, now that implies then if I want to get things by themselves, of course I could add 5x to both sides. Oops. Okay, 5x. So I'd end up with negative 7x on the left here plus 16. And here we would have negative 5x plus 5x is 0, so I'd have 3 subtract 3, which would be 0. Okay. And finally, this would mean that since I have, so if I subtract 16 from both sides now, I have negative 7x equals negative 16, which implies then that x is equal to negative 16 divided by negative 7, which of course the negatives cancel, like negative 1 on top and bottom. So I'd end up with an answer of 16 on 7. So our solution then would be the set which consists of just 16 over 7. Right, now they're not always simple with these kind of integer numbers in here. Sometimes we have fractions involved. So for example, let's suppose I have 3a plus 6 over 10 minus a half a is equal to 2 on 5a plus 33 on 5, and we want to solve this. Alright, now notice that we have fractions here, and of course we can only add things that have got the same denominator. So there's several ways to do this. Now the simplest way to do it is to look for a least common denominator. So in other words, a number that all of these denominators will go into, and the smallest one we're looking for. So we notice that 10 doesn't go into 2, 5 or 5, but certainly 2 goes into 10 and 5 goes into 10, so 10 looks like a good choice. So what we do is we multiply everything, and let's write a half a as a on 2. I'm going to multiply everything on the left by 10, and I'm going to multiply everything on the right by 10. And I'm going to distribute that 10, all right, across the addition, the subtraction here and the addition here. Notice we're using this particular equality rule here. So when I do this by 10, 10 divided in 10 is 1, so I really just end up with this. Notice it gets rid of the denominator. When I multiply here, 10, the 2's will go into 10, 5, so I'll end up with 5a here. Here, 5's into 10 go 2, so I'm going to have 2 times 2a, which is 4a. And here, 5's into 10 go 2 again, so it's going to be 2 times 33, which would be 66. Now we have it in the regular type of form, so here we're going to have a negative 2a, and I could subtract 6 from both sides, and we'll have, so if I'm subtracting 6 here, I'd subtract 6 here, so I'd have plus 60. Right, this is going to imply then if I put subtract 4a from both sides, I'm going to end up with negative 6a over this side is equal to 60, which means that a is going to be 60 over negative 60, which of course is negative 10. So our solution then is going to be the set that consists of just negative 10. Right, so that's how we do those types of solutions to a linear equation in one variable. Now there's a number of different kinds of equations. So let's talk a little bit about that. Now the ones we've just done above are what we call conditional equations. Now the reason they're conditional is that they're only true based on a certain condition. For example, if you look at this one up here, the first one, this particular example here is only true as long as x is equal to 16 on 7. Likewise with this second example, this equation here is only true on the condition that a is equal to negative 10. Okay? And so we have, it's true, right, based on a condition, and that is what the actual value of the unknown is. Right, so for example, let's suppose we just do a simple one again. Let's suppose I want to solve, and we want to identify the equation as being either conditional or not. Okay, so let's have a look at this one here. So let's suppose we have, say, 6x minus 9 equals 4x plus 13. Well, this would imply if I subtract 4x from both sides, and if I add 9 to both sides, this would tell me that 2x is equal to, now we have 13 plus 9 is 22, which implies that x is equal to 22 on 2, which of course is 11. And so this is conditional. In other words, it's true only if, alright, my value of x is 11. We also have another type which is called an identity. Now an identity is an equation that is true no matter what x is. What the unknown is. All right, and so for example, let's suppose I have something like negative 3 by 2x take 1 plus 5x is equal to 3 take x. Right, so this implies then that if I distribute here, I'm going to have negative 6x plus 3 and plus 5x is going to be equal to 3 take x. Now if I take this away, I'm going to have 3 take x is equal to 3 take x. If I add x to both sides, this implies that 3 is equal to 3. Well, this is true all the time, no matter what x is, and so this would be an identity. So in other words, this particular equation is true regardless of what x turns out to be, because we end up with a result like 3 is equal to 3, which we know is always true, and it has absolutely nothing to do with the value of x. The third type is what we call a contradiction. A contradiction is false or not true, all right, regardless of the value of the unknown. Regardless of the value of the unknown. And so if you look at an example of this, suppose I have 10 plus 14x is equal to 7 by 2x take 5. All right, this implies that, of course, that 10 plus 14x is equal to 14x take 35 if I distribute there. If I subtract 14x from both sides, this is going to imply that 10 is equal to negative 35, which is false regardless of what x is. It's always false, and so this would be a contradiction. So these are the three different kinds of equations that we should be able to identify.